Uh, in our last class, we learned how to use area decomposition to decompose a matrix. So, and just to review that part just for a couple of minutes. So these two things are given, like say coefficient matrix is multiplied by variable matrix is equal to constant matrix. Given, because this thing is given. Another thing is also we assumed, we'll prove this later, that A is also a combination of, product of lower matrix into upper matrix. Alright, these two things are given. These are facts. So from these two facts, we derived two different things. One thing we derived was LZ equal to C, LZ equal to C, UX equal to Z. Right? So we did this conversion. We showed how to convert. Now today's lecture really it's all about how to decompose a matrix using these two steps. Alright, so for example, if we have a matrix 2, 6, 9, 8, 11, 12, minus, or say not big minus, say 16, 20, how about 80. So this is a matrix. We can really decompose this matrix using these two steps. Today's lecture is just to show you how to decompose this matrix using these two steps. Hopefully that makes sense. Alright. So first of all, what you can do, we can use Gauss elimination to make this to a triangular shaped matrix. Alright, which should be upper matrix. So apply Gauss elimination. I'm pretty sure you all know how to apply Gauss elimination. So straightforward Gauss elimination. Step 1, which is for elimination of Gauss elimination. Then you can apply on this matrix to create upper matrix. So our objectives are to identify upper matrix and lower matrix of this matrix. So you need to identify these two matrices for this matrix. As simple as that. Now, what we want to do, we want to apply Gauss elimination onto this matrix to create our matrix, to create upper matrix. Alright, so we can consider this one, say row 1, this is row 2, and this is row 3. Right? So since we are using Gaussian elimination, we know we have to identify pivot, right? Here pivot is the first element. We all know that. So here pivot equal to 2. Alright, that's 2. Now we need to make this one 0 and this one 0. How do you do that? We can divide row 1 divided by the pivot element into the element you want to make 0, 2, which is 8. So if you really apply this operation onto row 1, this is row 1. So we can do like what we can do. We can do 2 by 2 into 8, then 6 by 2 into 8, and 9 by 2 into 8. Alright, so these two are gone, so 8, so we can call like 4, so we can go 24 and 36. So this is the modified row 1. So you can call it row 1 prime. Row 1 prime. The modified step of row 1. So we will converted row 1 to create this setup. Then as we know, to eliminate this element, we have to subtract from row 2. So from row 2 minus row 1 prime modified 1. Row 2 is what, your 8, then 11, 12, then this is 8, 24, 36. Right? So if we subtract, this one becomes 0, this one becomes what? 24 minus 11, so it becomes minus 13, and this one becomes minus 24. So this is really nothing but row 2 prime, right? So after this division, multiplication as well as the subtraction, the for row 2 this 8 became 0. Our objective was to make this to 0. We just made this one 0. Alright, we converted this one to 0. So when this thing got converted, so this row 2 prime, it became like, so this is not here 8 anymore, it became 0, and this is not 11 anymore, it became minus 13, and this one became minus 24. So same kind of operation can be done to make this one 0. Alright, just exactly same kind of thing we did in Gauss. So let me erase it a little bit. So with the same pivot, now pivot still 2 because we need to make all of them 0 below 2. We just made one 0. So let's make this one 0. So to do that, we have to convert again row 1. So row 1 divided by 2 pivot multiplied by 16 because I want to make this one 0. 16. Alright. So now what we can do, 2 by 2 into 16, then 6 by 2 into 16, 9 by 2 into 16. Alright, so we cannot really cancel this out. About we can call this one like 8 times 8 times. Alright, so this one becomes 16. 6 multiplied by 8, 48, and this becomes 72. So this is your row 1 double prime, because we made the first operation that we applied to make this one 0, we call it row 1 prime. So we can really call the same thing for another operation under the same row. So it is going to be row 2, row 1 double prime, row 1 double prime. So we did this before in Gauss many times, so this shouldn't be difficult for you. And then we want to make this one 0, so we have to subtract from row 3. Row 3 minus row 1 double prime. Row 3 is your 16, 20, 80, 60, subtracting row 1 double prime, which is 16, 48, 72. Now minus, minus, minus. This is gone. This one became 0. So here is 28. Here is your 8. So we can call this row 3 prime. Row 3 prime. Because we subtracted from this row, and this is the modified version of row 3, because we want to make this one 0, because that's what Gauss elimination does. So this is not 16 anymore after applying these two operations, this division, multiplication as well as subtraction. So this one becoming 0, 20 became minus 28, and 80 became 8. So essentially, so let me erase it out. Essentially what happened, so if I can let me keep a original copy somewhere down below. It was 2, 6, 9, 8, 11, 12, 16, 20, 80. So this was the original matrix. I'm just giving a copy of that. So this one is not that anymore. So this one got converted to, this is 0, this is minus 13, minus 13, this is minus 24, minus 24, this is 0, minus 28, and this is 8. So we proceeded further, but not quite there yet, because this part is not quite that triangular shape as of yet. Because if we can somehow make this one 0, then we get all upper elements. And if we can do that, we found our U matrix. So only one thing remaining for us to find out U matrix is to eliminate this part. As we know, once we have the pivot element identified and made all of them 0 down below, now it's about time we think about the next row and find the corresponding pivot. Here the pivot is minus 13, alright, because second row, second element is present, so you don't need any swapping at this point. No technical stuff as simple as that. So it's a naive Gauss elimination. We have our pivot. So here new pivot, we can call a new pivot is equal to minus 13. Minus 13. So we need to make this one 0 down below pivot. Only one element down below pivot. Alright. So we need to make this one 0. How do we do that? simple Gauss. So what Gauss did, you really convert. You want to convert this row and then subtract from this row. All right. So we can convert like a row 2. Let me make it bigger. Row 2 divided by minus 13 and multiply by minus 28. Minus 28. Now what happens? Row 2, actually this is row 2 prime, right? Row 2 prime, row 3 prime. Row 1 is, alright, we didn't touch row 1 because pivot is there, was there. So row 2 prime is 0 minus 13, 24. We're really changing, we're really applying this operation. Dividing minus by 13, minus 13, and multiplying by minus 28 because we have to make this one 0. So you'll see that how do we do that. So after applying this operation on row 2 prime, what happens? 0 by minus 13 into minus 28, then minus 13 divided by minus 13 into minus 28, then minus 24 by minus 13 into minus 28. Alright, so this part is 0. You can divide anything by 0 by anything or multiply by anything, it becomes 0. As simple as that. This one is 0, this one is minus 28, and this part is something like what? 24 into 28 by 13. So at this time, maybe if I can have a calculator that should help me. But I should have a calculator. Just a minute. Sorry, I don't see that calculator. Let me try to use this phone if I can. Alright, so here is 24 multiplied by 28 divided by 13. So that is, so minus plus minus should be minus 51.69, become 51.69. So 2 decimal point is good enough. Alright. So now we can call this row 2 double prime. We can call this row 2 double prime. Now we need to make this one 0. Alright, so we need to subtract from row 3 prime. So row 3 prime minus row 2 double prime. Row 3 prime is your 0 minus 28, 8. Now row 2 double prime is 0 minus 28 minus 51.69. Alright, so this one is minus plus. So this is 0. So this is 0 again, 0. And this one is becoming what? 59 plus 59.69. Right? So this is your row what? Row 3 double prime. Row 3 double prime. So as you can see, row 3 prime, this is the modified setup of row 3. So this is not this anymore. So it became 0, 0 and 0. This one becoming 0, 0, and then what else? Then it was, of course, what it was, minus 18, right? Minus 20. It was minus 20. We need to keep this record of this. Minus 20. It was minus 20. So this one becoming 0. And 8 becoming 59.69. So once we have that, like say, this is because these elements are 0 and this also becoming 0. Alright? So now we have the upper part, upper setup, upper triangle. So that is a U matrix. So U matrix is nothing but, so we can straight up from here we can say U matrix is so U matrix 0 3 double prime. So U matrix is nothing but let me clear this out. It is 2 6 9 0 minus 13 minus 24, and this is 0, and 59.69. Alright, so we found our U matrix. So that is our U matrix. See, it was that simple. How about L matrix? And that is not that difficult either. So let me use this out. So there is a rule for L matrix. For L matrix, so we need to find these elements. L11, 0, 0. We don't need to do the we don't need those elements for one matrix. We need L21, L22, and 0. We need L31, L32, and L33. So for one matrix, we need to find this setup. We need to solve for this setup. We can see that the upper elements are all 0. Not only that, for one matrix, the diagonal elements or L11, L22, L33, they are all 1. They are all 1. So we know this part. So these are all zeros, and all the diagonal elements are all 1. So we can really say this is 1, this is 1, this is 1. Now all we need to copy is L21, L31, and L32. What is L21? L21 is equal to A21 by A11. So these are the basic rules. You have to kind of memorize this one. L21 is A21 by A11. What is A21? A21 by A21, I mean the original matrix. That's the reason I kept that matrix down below. A21 is like coefficient of the original matrix of that particular position. A21 is 8. This is A22. This is A23. A21 is 8. So 8 divided by A11 is 2. 2. So this is 4. So we have our value 4. Right? How about L31? L31 is just like before, A31 by A11. What was A31? A31 16. A31 was 16 divided by A11 is 2. So this is what? 8. And lastly, L32. L32 is equal to equal to A32 prime by A22 prime. A32 prime by A22 prime. What do I mean by this? A32 prime is the element that we found out from this setup. Remember that when we converted all the elements of the first pivot below pivot 0, we got this. What did you get? We got like 2, 6, 9, 0, minus 13, minus 24, 0, minus 28, 8. So you really need to focus on that setup. Because from that setup you get your A prime, A32 prime. So A32 prime you get from that setup when you made all the elements down below first pivot 0. So when you have this setup, so this is all 0 and you have something here, some other values. So that may not be the same as original value. So because of these two elements are 0, these values have changed. So this is not 11 anymore. This is minus 13. This is not minus 24 anymore. 12 anymore. It's minus 24. It's not of course this one 0. It's not 20 anymore. It's becoming minus 28. And this is not 8 anymore. It became what? 8. So for that part, you really need to focus on that setup after first step where you make all elements down below first pivot 0. So here A32 prime is nothing but this minus 28. That's 32 prime divided by A22 prime. And at the time it was minus 30. So if we perform this operation, say here it's out. So 28 divided by 13. So 2.153, 2.15. So minus minus becoming plus. So 2.15. So your L matrix. So here we can write down L31 is like what? 8. And L32 is like 2.15. 2.15. Alright. So we just decomposed this matrix into lower upper matrix. So lower matrix is nothing but this. Let me put it here so it will make sense. It is 1, 0, 0, 4, 1, 0, and 8, 2.15, and 1. Alright, so we just decomposed a particular matrix to two different parts, upper and lower matrix, using LED decomposition. Alright, so next lecture we will cover how to use these two matrices to solve a set of linear equation. So for this, in this part, we just decomposed a given matrix that can come from a set of linear equations. These are nothing but the coefficients of a linear equation. Alright. So when we see that equation and create a coefficient matrix and apply LED decomposition to decompose that coefficient matrix to two different parts, then we can do some other operations to solve problems. We'll see that in our next lecture. Alright, thank you very much. Stay tuned for that. So that is it. Thank you.